Hello everyone and welcome to the project presentation of electrical engineering subject. I am Poojan Simariya and I have made my project on wind power generating plants. So these are the table of contents we'll be looking at. We'll go through introduction and we'll also get to know what is a wind power plants and the parts of our wind power plants. We'll go through the working. We'll also get to know advantages, disadvantages, types of wind power plants, etc. So here's the introduction. As the world continues to focus on sustainable energy solutions, the importance of renewable energy sources cannot be overstated. One such source is wind power, which offers a clean and abundant source of energy. These convert wind energy into electrical energy exactly as opposite as our fans in our home. They typically consist of multiple wind turbines, which are tall structures with large blades that rotates and converts wind energy into electrical power. Wind power plants are also known as wind power stations or wind turbine farms. Now we'll look at why should we use wind power. Wind power, first of all, is very abundant in nature. It has always given necessary propulsive force for ships and windmills, and in current it runs aeroplanes and wind power plants, etc. It has always helped us. And in short, we can all say that air is always there. It is always a inevitable part of the nature. Let's see what exactly is a wind power plant. A wind power plant is an installation of multiple wind turbines in a specific area to harness wind energy and convert it into electricity. Wind turbines capture the kinetic energy of the wind, which rotates their blades, generating electricity through a generator. These plants are strategically located in areas with consistent wind patterns. The electricity generated is transmitted to grid for distribution to consumers, and wind power plant contributes highly to renewable energy generation, environmental sustainability, and energy diversification. Now we'll look into the parts of a wind power plant. The major components of a wind power plants are these rotating blades, which are known as wind turbines. The towers on which the wind turbines stand upon. These are the electrical infrastructures, we can say, which helps transplace the electricity generated through the wind power plant to our homes. And there are also control systems in the wind power plants which help reduce the wind speed and etc. So, here we'll describe the parts of the wind power plant which we saw in the last GIF. First of all, wind turbines. The most essential part of a wind power plant are the wind turbines. These structures captures the kinetic energy of the wind and converts it into mechanical energy through the rotation of their blades. And then this mechanical energy is converted into electricity through a generator. Next, we have towers. Wind turbines are mounted on tall towers to increase their exposure to the wind. The height of the tower is an important factor in determining the efficiency of a wind turbine. Next, we have electrical infrastructures. Wind power plants are connected to the electrical grid through a system of power lines, transformers, and other equipments. This infrastructure enables the electricity generated by the wind turbines to be transmitted and distributed to the consumers. Lastly, we have control systems. Wind power plants are equipped with sophisticated control systems that monitor and optimize the performance of the turbines. These systems can adjust the pitch of the blades, the orientation of the turbine, and other parameters to maximize the energy production. We have looked into the major components of the wind turbines. Now we'll look at the small but really important components of a wind turbine. First of all, wind van. The wind van measures wind direction. This is a wind van in diagram. It measures wind direction and communicates with the yaw drive. There is a yaw drive here. So it communicates with the yaw drive to orient the turbine properly with respect to the wind. Similarly, we have an anemometer. This cup-like thing is an anemometer which measures wind speed using these rotating cups. They provide crucial data for wind resource assessment, turbine optimization, and overall plant operation, ensuring maximum energy production efficiency. Then we have this nacelle. This nacelle is at the top of the tower and contains the gearbox, low and high speed shafts, the generator and brakes, etc. Next we have generator. The generator, this is the main part. It is driven by the high speed shaft, and it is the main part which generates the electricity. Copper windings in this generator turn through a magnetic field in the generator to produce this electricity. Then we have a yaw system. It rotates the nacelle on upwind turbines to keep them facing the wind when wind direction changes. These are yaw system. Then we have brakes as well. These brakes are not like the brake in a car. Turbine brake keeps the rotor from turning after it's been shut down by the pitch system. Once the turbine blades are stopped by the controller, the brake keeps the turbine blades from moving, which is necessary for maintenance. Uh, Next, we have this gearbox. Gearbox adjusts the turbine's blade speed. It amplifies for it speed for efficient electricity generation, converts varying torque into a consistent output, etc. Here we have our gearbox, here as you can see in the diagram. Lastly, we have shafts. Shafts transfer rotational energy from turbine blades to the gearbox and to the generator. We can see the high speed shaft and low speed shaft in this picture. After looking at each component in a wind turbine, we'll now look at the working of a wind turbine, which is the most important part. Wind turbines works on a really simple principle. Instead of using electricity to make wind, just like in our fans at our home, wind turbines use winds to make electricity. A wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which work like an aeroplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag forces. The force of the lift is stronger than the force of the drag, and this causes the rotor to spin. The rotor connects to the generator through a shaft and a series of gears in a gearbox. It speeds up the rotation. This translation of aerodynamic force to rotation of a generator creates electricity simply. Let's look into each step of this working. So these are those simple steps which convert wind into electricity. First of all, the wind turbine operation. When wind flows over the turbine blades, it causes them to rotate. This rotational motion is transferred to the turbine shaft. The shaft is connected to a gearbox which amplifies the rotational speed to drive the generator. The second step has electricity generation. Inside the nacelle, the generator converts the mechanical energy from the rotating shaft into electrical energy. The electricity is generated is then transmitted through power cables to a substation located within the wind farm. The third step is grid connection. At the substation, the electricity is converted to a higher voltage for efficient transmission through the electrical grid. The grid connection enables the distribution of electricity to end users such as homes, business, etc. Last step is about controlling and monitoring. Sophisticated control systems monitor various parameters, including wind speed, turbine performance, and grid connections. These systems optimize turbine operation for maximum energy capture, and it also ensures safe and reliable power generation. Let's look at the advantages of using the wind power plant. First of all, clean and renewable energy source. This as these are producing zero greenhouse gas emissions and are also helping reducing air pollution. Secondly, low operating costs. Of course, wind power has lower operating cost compared to traditional fossil fuel plants, leading to lower electricity prices for consumers. It also has reduced pollution and it is also sustainable because it is more sustainable and environmental friendly alternative to fossil fuels which emits harmful pollutants and are in finite resources. Next, we have reduces the usage of fossil fuels. Of course, it reduces usage of fossil fuels, and by reducing our reliance on fossil fuels, wind power helps combat climate changes and promote sustainable energy practices. Lastly, we have abundant supply, as we have already known that air and wind are already abundant in the nature. As for everything that has advantages, it also has disadvantages. In this case, there are chances when there are inconsistent and unstable winds flowing. Wind is unpredictable and it does not always blow when electricity is needed. Also, other problems are like high initial costs. It really requires high initial costs to develop a wind power plant. These are loud and noisy. It also highly affects bird lives. There are many problems such as noise produced by the rotor blades, aesthetic or visual impacts, and sometimes, as mentioned, birds have also been killed by flying into the rotors. According to some reports, almost 20,000 birds die annually due to wind power plants. Uh, these are really far from places requiring electricity. Good wind sites are often located in remote locations, far away from cities where the electricity is needed. Also, it has complex design and are really not very easy to transport this wind turbine. Now we'll look at the types of wind power plants. First type is onshore wind power plant. These are located on lands and easy to access for construction and maintenance and are cost effective. Secondly, we have offshore power plants. These are located in bodies of water. Higher energy production. It also requires specialized technology and infrastructure. Lastly, we have hybrid wind solar plants, which combine wind turbines with solar PV panels. Uh, and it also harness renewable energy from both wind and sunlight. This is a picture for onshore, offshore, and wind and solar plants. Lastly, we have types of wind turbines. There are two types of wind turbines mainly, HAWT and VAWT, horizontal axis wind turbine and vertical axis wind turbines. Uh, this looks like this, and the vertical ones are in designs like this. Concluding my project, overall, wind power plants have become an increasingly popular source of renewable energy around the world due to their ability to generate electricity without producing greenhouse gas emissions. They are a key component of efforts to transition to a more sustainable and environmentally friendly energy system. These are the references I've used, and that is it from this presentation. Thank you.